Today, we are going to start a new series about trusses, and this is example one. So, in this example, you have to find the forces in all the members of the truss, and you have to also state that whether the members are in tension or compression. So, you see the point A and D are connected with the walls by a pin and a roller joint. So, at point A, there are two reaction forces acting, and at point D, a reaction force is acting. So you also seeing that at point B, a force P1 is acting vertically downward, which is equal to 6 kilonewton. And at point C, a force P2 is acting, uh, which has a value which is equal to 9 kilonewton. So first of all, we are going to find the reaction forces which are acting at point A and B. So when we take movement at point A, so we get force at point D, which has a perpendicular distance of about 12 meters. And we have negative force 6 kilonewton, which has a perpendicular distance of 4 meters. And we have negative 9 kilonewton force, which has a perpendicular distance of 8 meters. So it is equal to 0. So we get force at point D, which is equal to 8 kilonewton. And as you see, when we apply movement at point D, we get force at point A in the y direction. So the force AY is equal to 7 kilonewton. And when we apply our force in x direction, so we get uh, force at point A in x direction, which is equal to 0. Before solving the question, you must know that to solve a truss, we can separate the parts of a truss. So it makes easy to find the forces in the members. Basically, there are two methods to find forces in the truss. One of them is the method of joint, and one of them is method of sections. When you have to find the forces in other members of truss, then you can apply method of joint. And when you are asked to find the forces in a particular members, then you can apply method of sections. You see, in this example, we have to find the forces in all the members. So I am going to solve this uh, problem by using the method of joints. And also note that in a member, two type of forces act. One of them is tension force, and the other is compression force. So to solve this, you have also you to also find the angles which the axis make. So you see that this makes us square. This makes us square. So you see that if we take this truss and this line and this number, so it makes a right angle to so using this we can find angles. So let's continue to solve this problem. So if we take point A, we know that two reaction forces are acting, which we have found already. And these are the forces that are acting on the members of the truss. So the angle which these members made is 45 degree. So when we apply force in y direction, we get 7 kilonewton force plus force in the member A, which is vertical component sine and angle 45. So we get force in the member A, which is equal to minus 9.9 kilonewton. You see that uh, that there is an active sign in our answer, so it means that our member is in compression. And when we apply force in x direction, then we get diagonal force plus force in AB member plus force in AE member. And now we use its horizontal component. Uh, it has also an angle of 45 degrees. So the force in the member AB is equal to 7 kilonewtons. You see that there is positive sign. Now, so it means that the member is in tension. So if we take point D, it means we have only one reaction at point D. Um, so the angle which these members made is basically about 45 degrees. So when we apply force in y direction, we get the force in member D, which is equal to minus 11.3 kilonewton. You see this member is in compression. And when we apply force in x direction, then we get force in the member CD, which is equal to 8 kilonewton. You see this member is in tension. So you see at joint B, a force is acting vertically downward, and there are three members that are connected with the joint B. And you are seeing that the angle between these two members is about 71 degrees. So when I apply force in y direction, then I get minus 6 kilonewton force, which is force B1 plus F force in the member BE with its vertical component sine 71 degree. So the force BE is equal to 6.3 kilonewton and it is in tension. And if you take force in x direction, then you get minus 7 kilonewton force plus force in member BC plus force in member BE with horizontal component at angle 71. So you get force in member BC, which is 5 kilonewton. You see this member is in tension. So when we take joint C, so the angle is about 71 degree. And when you apply force in y direction, then you get the member. Then you get the force in the member C, which is equal to 9.5 kilonewton, and it is in tension. And when you apply force in x direction, then you get FCD, so which is equal to 8 kilonewton.